So today we're going to learn the basics of networking, and I have to admit this was a really challenging video for me because networking is just about my favorite thing in the entire world to do, and trying to limit it to just the very basics was really challenging. So I want to talk about what TCP networking is, like IP version 6, version 4, some DNS stuff. I just want to cover the very basics of networking so you understand what's going on when people talk about your computer being on like a local network and that sort of a thing. Okay, I want to start with the simple task of explaining the entire internet. Well, maybe not the entire internet, but let's say that everybody on this particular street that we're looking at, I don't know what this street is, we'll call it Oak Street. Everybody has a connection to the internet. So they all pay for like cable modem or DSL or something. And every one of those has a connection of some sort, whether it's cable or phone line or something coming into their house, and it connects to their router. Now, you probably are familiar with a router. It's, that box that your internet service provider plugs into, and every one of those houses has an IP address, and we're going to say it's an IP version 4 address because, well, it almost certainly is, right? And what that means is it has a format like 1.2.3.4, or there's 4 octets of numbers from 0 to 255, and that is what an IP address looks like. And every house has one IP address. However, inside that house, there are all sorts of devices. There's tablets, and there's phones, and there's television sets, and all of them have IP addresses inside the house. But you've probably seen this address probably looks familiar. You're like, oh my gosh, that's the address that's in my house. And that's because something like 192.168.1.1 is a reserved private IP range or IP address, an IP network that everybody in every house is able to use. So what that means is your router, this box here, it actually has 2 connections, one that connects to the internet and one that connects to all the devices in your house. Now, this connection can be wireless or it can be Ethernet cables, but the inside of your house has its own network, and it's usually something like 192.168.1. something. So you can have like a tablet that has 192.168.1.5. You can have a television that has 192.168.1.30, and they all connect through a single IP address, and the router does the job of routing packets from the internet in through this single IP address and then into the various places inside your house. So every house only has to have one IP address that is actually connected to the internet, and the router does the job of deciding who inside your network gets all the packets that are going out. Now, next door, they'll have an IP address as well. It's a unique IP address. It can't be the same one because they all have to have their own address on the internet. And this one is, let's say, 1.2.3.5. Well, inside this house, they can still have 192.168.1.1, and they can have a tablet with 192.168.1.5, and they can have a TV with 192.168.1.6, and all of them connect to the internet because the router decides, okay, so you wanted to go to the internet, so it uses its one single address on the internet, and it routes traffic into the individual devices inside. Now, the kicker is this tablet here can never talk directly to this television here. It has to go through the router, through the internet, and then back here. And that's because they're not connected on the same network. That's how they can have similar network addresses and not conflict, because these are only in existence inside a house. Now, again, that's a very simplistic view of what's actually happening, but that means the underlying truth that I'm trying to get across is that houses only have one IP address on the internet. They only have to have a single IP address, even if they have 1,000 devices inside. So a house could be a university. A university might have a single IP address on the internet, and the router connects to thousands of devices inside and determines how they get to the internet. And it's really good that we can do this because there are only a finite number of IP addresses on the internet. In fact, it's a very easy number to calculate. With IP version 4, which is that format that we're just talking about, where there are 4 octets or 4 sets of numbers separated by periods, and each one of those numbers can go from 0 to 255. Well, if you do the math and you iterate all of that, it means that there are 4,300,000,000 IP addresses available. And that might seem like a lot of IP addresses, right? Because there are, what, 8 billion people roughly on the earth right now in 2022. And that means that everybody can, well, I guess that doesn't work, right? Because that's not even one IP address for everybody. Because 4.3 billion addresses is not even close to enough. Think about how many devices you have right now on my person. I have a watch that has an IP address. I have the phone in my pocket has an IP address. Let's see, there's a tablet on my desk that has an IP address. Heck, my GoPro here, it actually has an IP address that connects to my local network. So there are not enough IP addresses to go around. Even if everybody just got one, there's not enough. Now, we solve that in a couple of ways. One is, like I said, we use those internal LAN networks and do a network address translation that allows every house or every business or every college to use a single IP address. But that doesn't make it all better. That's still, there are just not enough IP addresses for all of the devices that we have to use. And what about when we go to another planet, right? We're going to have things on Mars with IP addresses, and we just don't have enough. And so that's where IP version 6 came from. You've probably heard of IP version 6. It's okay if you're not familiar with it. It really hasn't caught on in a big way because we've gotten so darn good at using IP version 4 with our internal networks. And like cell phone companies will share a single IP address over hundreds of phones, etc., etc. So we've done an incredibly good job of managing the IP version 4 space. However, it is going to come to an end. We're not going to be able to use IP version 4 forever. And IP version 6 uses a similar concept, but a different numbering scheme. So instead of a number from 0 to 255 in one of every 4 places, we have 8 places with 4-digit hexadecimal numbers. And each one of these can go all the way from 0 to FFFF. And there, instead of 4 of them, there are 8 of them. So that's a lot. And again, they enumerate hexadecimally, so it can go all the way from 0000 to 00 or to FFFF. And this is what an IP version 6 address looks like. Now you can shorten it, like see how there's a couple of zeros right here mushed together. You can actually represent a whole bunch of zeros by doing like 2 colons right next to each other. So you can actually get it a little bit shorter looking. And over here we have 0001. Well, you can just shorten that to a 1, but still IP version 6 addresses are larger and more complex than IP version 4. But what that does for us is it gives us 340 undecillion possible IP version 6 addresses. Now, I know this is a number that we cannot comprehend, right? I mean, 4.3 billion is hard to comprehend. 340 undecillion is not possible for us to comprehend. So I thought a comparison here might be helpful. Every grain of sand on the planet Earth, including deserts and oceans and beaches, accounts for approximately 10 sextillion grains of sand. Now, if you look, there's 1, 2, 3, 4, 5, 6, 7 groups of zeros in how many grains of sand are on planet Earth. And this is an upward estimate, right? This is the high estimate of how many grains of sand are on the planet Earth. If you look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sets of zeros in the IP version 6 scheme. So that means we would have, let's see, 1, 2, 3, 4, 5, 6, 7. So that means we have this many. So what is this? Let's see, 100,000. So that'd be billions, trillions. So we could have 999 trillion planet Earths full of grains of sand before we would exhaust the IP version 6 number of available addresses. Now, I know that's kind of silly math, but what I want to get across is when we move to IP version 6, this isn't just an incremental step until we run out of IP version 6 addresses. We're not going to run out of IP version 6 addresses, right? It's just not going to happen. So when we make that transition, it will make things easier. The problem is we're so good at IP version 4 right now with having an internal LAN address and stuff that it's been slow to be adopted. But it is happening, and it will happen. And when it does, we're going to be fine. And what that will mean is every single device will have its own live IP address on the internet. So we don't have to worry about like my tablet conflicting with the neighbor's tablet. They will each have their own IP address, and it will be a real IP address on the internet, not behind a router that's doing network address translation. Now, we went over all that just so we could go over how to handle networking on a Linux box. And there's two different ways I'm going to show you to do some basic network research on a Linux box. There's the old way, which honestly doesn't feel that old to me because I still use these tools myself quite a bit. But then there is the new way, which you'll see on newer systems, and it's going to be on newer exams and things like that. And these methods work the same. They just use different tools. So we're going to look at both ways. We're going to see how you can find out the IP address on your system, how your packets are routed from the internal network to the internet, and then Netstat will just show things like ports that are on your system listening. Like if you have a web server running, it's listening on a port on your IP address, etc., etc. And then we'll show you the new ways of doing those same things. So I'm here on Ubuntu and I have both of the old tools and the new tools installed. The new tools came default. I had to install a package called NetTools in order to get the older tools. But how I used to do it, and it will still work on a lot of systems, is if you type ifconfig, so interface ifconfig, it will show you the interfaces on your computer. Now, every device has a local host, which means basically this is the computer's way of saying me on a network. It refers to itself, and this is the local address for, it's called localhost, and it's just how the computer talks to itself, right? Every single computer and device has this same address. It's just the way of saying me, okay? So you can talk to yourself, you can send packets to yourself on the localhost or loopback interface. But as far as network connections on a local network, that's where this comes into play. And we can see our internet address, or our iNet address, IP version 4 in this case, is 192.168.1.171. So this is our internet address. Now look, I do on this computer actually have an IP version 6 address too. And you can see there it is. It's a fully formed IP version 6 address. So it's live on the internet right here on my local computer. So we have both IP version 4 and IP version 6. And ifconfig is the way that we would look that up. But you can also use the newer tool, which is IP, and then you want it to show the address, and you can say show, and it will do similar. It's a different format, but it's the same type of stuff. So our loopback interface, here's our loopback address, and then down here we have our IP version 4 address, and here's our iNet version 6, IP version 6 address, and they're both here. It's just a little different format, but it's there. Now, the nice thing, though, about IP address show is that you can shorten it. You can just say IPA, there's a space there, but IPA, and it will show the exact same thing. Okay, so let's clear the screen. The next thing we can look at is our route. All right, so this is how we get out of our local network. And there's not a whole lot of routing information here other than this is our local network, 192.168.1.0, and .0 just is referring to our network, the whole network itself, okay? And so what it's saying is anytime you want to talk to a computer on this network, it just goes directly out this interface. We just talk to them directly. However, if we're trying to get somewhere else, we go to our default, which is Arbuckle, which unfortunately, it actually showed the DNS name here, but it's 192.168.1.1. So we could actually do route-n and have it not look up the address or the DNS names. And that's where we see if we want to go anywhere else on the internet, we would use our gateway of 192.168.1.1. And that is our inside part of the router. And then the router handles it from there with its one single public IP address. Now, the other way that we could look at our routing information is with the IP command again, but here we would say IP route, and it would show us our route, which is the default route right here. Okay, so that shows us the same information with a different way or with a different tool. And then the last tools I want to show you is Netstat, which is the older tool. And I know this is funny, but Netstat-tuna. These are the flags that will show you really good information about how the network interface is listening on the local network. And I can just never forget -tuna just because it's such a silly thing. But it's a string of arguments that will give us very useful information. So Netstat-tuna, and it will show us that we are listening. So here it says that the port is listening, and it looks like we're listening on port 53 right here. We're listening on port 631 right here on our local host IP address, and this is a printer port actually. Here on our public IP, or public inside our house anyway, we're listening on port 68. And there's actually an established connection on port 68. So these are just all of the information about how our computer is listening for things on the network. Now, the other way you can do that is with the SS tool. It's instead of Netstat, it's just SS, and it accepts the same -tuna. So we can do that. And actually, SS-tuna sounds like a fishing boat, but SS-tuna will give us similar information in a slightly different format. So you can see that it's listening, what port it's listening on, etc., etc. Like, for example, it's listening on all IPv6 addresses. This 0.0.0.0 means it's listening on everything, on all of its network interfaces on port 631, all that sort of thing. So anyway, these are the commands that we can use to see the networking on our local computer. And the only other thing I want to show you or explain is DNS. And DNS stands for Domain Name Server or Service. And basically what it means is all the computers, all the devices on the internet have an IP address, right? We've looked at some of those, like 1.2.3.4 or whatever it might be. They have a number. But if you want to go to a website on the internet, you don't know its IP address, right? I mean, that's just not something that you're going to remember. So you need to be able to resolve that to a name. Something like google.com resolves to an IP address. And that's what DNS does. DNS takes an easy readable name and it will translate it into an IP address that your computer can actually find on the internet. And so that's how DNS works. Now on our Linux system, there's a couple ways we can configure that, and I want to show you, but conceptually, that's what's going on. We're just taking a name like google.com and looking it up in a table, our DNS servers table, and then turning it into an IP address so that we can visit that site. Now, the simplest way we can do that is if we look at the etc. hosts file on any Linux system, there's going to be just some text here. For example, 127.0.0.1 is localhost. And what that means is it's creating a DNS record internally that will resolve the word localhost so that our computer sees that as 127.0.0.1. The same thing down here for some IPv6 stuff, but you can add things into here if you want and create your own DNS entry in etc. hosts. Now, obviously, we can't keep a record of the entire internet in our etc. hosts file. So what we do is we reach out to a DNS server. And if we look in etc. resolve.conf, notice there's no E, it's resolv.conf, we can see where it tells us what name server to use. Now, in our case, the name server or the DNS server that we're going to query for DNS lookups is 127.0.0.53. Okay. And what that means is every time we have to say like, okay, what is the IP address for google.com? It's going to query this server, and we have to reference this server by IP address because otherwise it's like a chicken and an egg thing, right? How do we know the name of our DNS server before we ask a DNS server? So we have to reference the DNS server by an IP address itself. And what we would do to query that thing is we would say something like host google.com. And so what we're doing now is saying, okay, 127.0.0.53, what is the IP address for google.com? And it will reply with actually quite a bit of information. It'll say, well, google.com has an IP address of 172.217.0.174. It also has an IPv6 address of this right here. And all of this other stuff down here, mail, we won't worry about that right now, but this is just other DNS information about the google.com domain. But notice it gave us an IP address for google.com, which is just awesome. And we can test to see if we can connect to it by doing the ping command. What ping does is it sends a packet of information to an IP address and waits to hear if that responds back. So we can say ping 8.8.8.8, which is an IP address for a Google DNS server, but it's just easy for me to remember that I know 8.8.8.8 is a live IP version 4 address. And if we ping it, we get a reply. Okay, so yes, it says absolutely, we got a reply from it. So I'll hit Control C, but we could also do ping google.com, and then the ping command will query our name server up here and say, okay, I need to know the IP address for google.com. It will return this IP address, and then it will try to ping that IP address. And look at that, 127.217.0.174 is what's replying to our ping. Again, I know that was a whirlwind of information about networking, and we just barely touched the surface of all the things that we can do on a Linux system with regards to networking. But hopefully you understand kind of how the internet works when it comes to IP addresses and what IP version 4 and IP version 6 are, because that's important for you to understand what's going on, especially when it comes to looking up like google.com to an IP address. Like what's actually happening? Oh, it's just like a list of names that point to IP addresses, because IP addresses are how things get communicated to over the network. Anyway, Linux is a very powerful tool to use on networks, local networks, and the internet, and it's, you know, as a larger beast. So the more you understand about networking, the more efficient and the better network administrator or Linux administrator or just IT person you're going to be at your job. Anyway, this was a lot of fun. I can't wait to do more in-depth networking stuff with you in later videos. But anyway, until next time, learn everything, do what you love, and most importantly, be kind. I'll see you at the next video.